morning, children. As we had done a few problems on permutation, let us in detail discuss the formula. Permutation as a mathematical concept, we define it as a bijective mapping on the set. Suppose the set is containing, let me take S3, it is containing A, B, C. We want to write an onto mapping on S3. A, B, C, I can take as A, B, C. This is one mapping. This is one and onto. I can also say A, B, C may go to A, C, B. Another mapping, A, B, C can go to B, A, C. Like this, how many can I create? A, B, C can go to B, C, A. A, B, C can go to C, A, B. A, B, C can go to C, B, A. Each one I call a permutation. So in S3 tells me there are 3 elements. Here we have taken S and N elements. I can create 1, 2, 3, 4, 5, 6 such permutations, or I will say 3 factorial. So in S3 I can create 3 factorial onto mappings, which I can call as permutation. In Sn, where there are n elements, I can define permutation as a bijective mapping. Bijective tells me 1 and onto. On the set S onto itself. ABC to ABC only. If I take ABCD, I must take ABCD and all possible combinations. So this is a basic idea. The very next thing, how to write the formula for NPR. If I want 5P3, which we discussed in the previous class, 5 into 4 into 3. Start from 5, less 1 number, 3 I have to write 3 elements. 5P2 tells me 5 into 4. The same idea, here we have done NP2, NP3, NP4 like that. How about NPR? Start from N minus 1, N minus 2, keep on writing. How I get this number actually? It is 5 minus 3 minus 1. 5 minus 3 minus 1. How I write this one? 5 minus 2 minus 1. Like this only we write. So here the formula will be N minus R minus 1. Or I can write N minus R plus 1. So N minus 1, N minus 2 and so on up to N minus R plus 1. That is the formula for NPR. Writing this is easy when it is 2, 3, 4 like that. When the number is too big or when I don't even know this R, this formula which we used in the previous class is easy. Suppose R is bigger than N. Can it be? No. Out of N, I can select and arrange R at a time. R should not be more than N. So we need to define that also. If R is more than N, we will take that answer to be 0. So these are the different formula which we used in the earlier class. Number of permutations when it is repeated. When repetition is allowed, we had N power R. The next formula, NPN and NPN minus 1 are equal. What is NPN actually? It is N factorial. So LHS is N factorial. What about RHS? Use this formula. N factorial by N minus R factorial N minus 1 factorial. N and N cancels. N factorial by minus into minus plus 1 factorial. 1 factorial is 1 only. So my answer is n factorial. I am able to show LHS and RHS are equal. So we get the formula NPN equals NP n minus 1. The next formula n into n minus 1 PR minus 1 is nothing but NPR. We know NPR formula, that is RHS. Check whether LHS is the same. N into. Apply the formula. In the place of n I have n minus 1. R becomes R minus 1. So n minus 1 factorial by n minus 1 minus r minus 1 factorial. N minus 1 factorial, n minus 1 minus r minus 1 factorial. N into n minus 1 factorial becomes n factorial. Here n minus 1 minus r minus into minus plus 1. Plus and minus cancels. I am left with n factorial by n minus r factorial, which is the RHS. So these are simple formula but used in some of the objective type problems. The very next form, number of permutations, n objects where p objects are of same kind. The example that we did, Mississippi. So we had problems like this. Total number divided by whichever is repeating that many factorial. So as we do problems today, we will apply the formula. Exercise 4.2, question number 11. In how many ways 4 maths books, 3 physics books, 2 chemistry books and 1 biology book can be arranged on a shelf with same subjects together? How many maths books are given? 4. The condition is all the subjects are together. That is, all the maths books are together. Among the 4 maths books, we can arrange them in 4 factorial ways. That is 1 into 2 into 3 into 4, 24. 3 physics books among themselves can be arranged in 3 factorial ways. 1 into 2 into 3, 6. 2 chemistry books can be arranged in 2 factorial ways. 1 into 2, that is 2. 1 biology book can be arranged in 1 factorial way, that is 1. The 4 different subjects we can change. Maths, physics, chemistry, biology, or physics, chemistry, biology, maths, like that. Among the 4 subjects, I can shift in 4 factorial ways. 1 into 2 into 3 into 4, that is 24. Total number of arrangements, multiply it all. 24 into 6 into 2 into 1 into 24, and your answer is 6912. So this many arrangements are possible. Question number 12. In how many ways can the letters of the word success be arranged so that all S are together? Success, there are 7 letters, but the condition is all the S's are together. 1, 2, 3 S's put together, they are all the same letters. However, I arrange, it will be only one arrangement. So 1, 2, 3, 4, 5. Totally 5 letters we will consider. Because the S's are together, consider this as 1 unit. Consider this as 4 units. Altogether 5 letters are 5 units, I can say. So the 5 letters can be arranged in how many ways? 5 factorial ways. In that, there are 2 C's that are repeated. So 2 C's can be arranged in 2 factorial ways. Total number of arrangements, divide 5 factorial by 2 factorial. 1, 2, 3, 4, 5 by 1 into 2, that is 60. So 60 possible ways we can arrange the word success in such a way that all the S's are together. Question number 13. A coin is tossed 8 times. How many different sequences of heads and tails are possible? A coin is tossed. Either head will come or tail will come. So there are only 2 possibilities. When it is tossed 8 times, first time, second time, third time, each time there are only 2 possibilities. So 2 into 2 into 2, how many times? 8 times we have. So what is my answer? 2 power 8. That is 256. So 256 is a different sequences possible. The second subsection. How many different sequences containing 6 heads and 2 tails? 8 coins are tossed, 8 heads are possible. But I want only 6. So from 8, we want only 6. But 6 heads will look alike. So the repeated permutation divide. 8 possibilities are there, but I want only 6. If 6 are heads, naturally the remaining 2 are tails. Divided by, since heads are alike, we divide by 6 factorial. So what is my answer? 8, 7, 6, 5, 4, 3. 6 numbers I have to write. Starting from 8, less 1, 1. 6 numbers. 1, 2, 3, 4, 5. 6 numbers I have to write. Divided by 1, 2, 3, 4, 5, 6. You can cancel and your answer is only 7 and 4 are left out. 28 ways. So the second subsection containing 6 heads and 2 tails, my answer is only 28. Question number 14. How many strings are there using the letters of the word intermediate if the vowels and consonants are alternative? What do you mean by the word alternative? There are 6 vowels and 6 consonants as I list out. Totally there are 12 letters. If vowel comes here, consonant must be here. Again vowel and then consonant. So they are placed like that way. So let us check 6 vowels, how they will be arranged. This implies 6 factorial divided by 3 E's are repeated, 3 factorial. 2 I's are repeated, 2 factorial. 6 consonants. So this also 6 factorial by. There are 2 T's repeated. So 2 factorial. So vowels alone we have seen the arrangement. Consonants alone we have seen the arrangement. Suppose the vowels in odd places and consonants in even places. What is my answer? 6 factorial by 3 factorial, 2 factorial into 6 factorial by 2 factorial. Simplify the answer. We get 1, 2, 3, 4, 5, 6 by 1, 2, 3, 1 into 2. Again 1, 2, 3, 4, 5, 6 by 1 into 2. As we cancel 1 to 6, 1 to 6, 1, 2 we can cancel. It is 16 into 1 and 2, 1 and 2 cancels. So it is 316. Together it is 21600. Vowels in even places and consonants in odd places. This is also correct because our question is alternative. So if I change vowels in even and consonants in odd, the same argument, I get 21600 because I will multiply like this. Total. So alternative arrangement. We have to add both. 21600 plus 21600, we get 43,200, and this many ways we can arrange. The second subsection, all walls are together. How many walls are there? Actually 6. Put the 6 together. The 6 alone can arrange themselves in 6 factorial by 2 is 3 is 2 factorial 3 factorial. Totally, all these are together in this is the arrangement. Totally, how many units are there? 1, 2, 3, 4, 5, 6 and then 7. So the 7 units divided by 2 t's are repeated. So 2 factorial. For this walls together we have a separate arrangement. This together can come here or here or here, anywhere. So count this as 1 unit and this as 6 units. Together there are 7 units. In the 7 units, these 2 are repeated. So 7 factorial by 2. So total arrangement, let us multiply 6 factorial by 2 factorial and 3 factorial into 7 factorial by 2 factorial. We get 1, 2, 3, 4, 5, 6. Simplify the answer yourself and check whether it is right. We get 151200. We'll see the steps. All walls together, the arrangement is 6 factorial by 2 factorial into 3 factorial. But these together can come anywhere. So consider them as 1 unit. NTR, MDT as the remaining units. Altogether 7 units. The 7 units we can arrange 7 factorial by 2 factorial. Total arrangements will be to multiply both. As we multiply, we get 151200. The third subsection, the walls are never together. This is all walls are together. Here they are never together. So the complement is here. So let me find the total. How many letters altogether? 12 letters. Can be arranged in how many ways? 12 factorial divided by how many letters are repeated? We shall check. The i's already we have done 2 factorial, the e's 3 factorial and the t's 2 factorial. Find out this answer. So this is total number of arrangements. In that, let us subtract walls together from the second case. So the walls together we have 151200. From this answer subtract so that we will get walls not together arrangements. So we need to just calculate and simplify. So walls not together arrangements will be, just subtract total minus walls together. Simplify the answer. We get 19807200. Be patient enough to calculate by cancelling 2, 3, 2 factorial. The remaining you need to multiply, from which you subtract the second subsection, that is the walls all together. As I subtract, we get the number of cases when the walls are not together. Fourth subsection, no two walls are together. How many consonants are there? 6. The 6 consonants, there is no restriction. So 6 consonants can be arranged in 6 factorial ways, but 2 t's are repeated. So divide by 2 factorial ways. Now the walls are not together. implies 1, 2, 3. So these are the places where the walls can come. 3, 4, 5, 6, 7 places. 7 places for the 6 walls. So there are 7 places for the 6 walls. So I can arrange in 7p6. But 2 i's and 3 e's are there. So divide by 2 factorial and 3 factorial. Now the total number of strings with no 2 walls together multiply. This is consonant arrangement and this is wall arrangement. Multiply 6 factorial by 2 factorial into 7p6 by 2 factorial into 3 factorial. 6 factorial, the formula 1, 2, 3, 4, 5, 6 by 2 factorial 1 into 2. 7p6 meaning 7, 6, 5, 4, 3, 2. I must write 6 numbers divided by 2 factorial 1 into 2, 3 factorial 1 into 2 into 3. Cancel, simplify and find out the answer. We get 151200 and that is the answer. Exercise 4.2, question number 15. Each of the digits 1, 1, 2, 3, 3 and 4 is written on a separate card. The 6 cards are laid out in a row to form a 6-digit number. How many distinct 6-digit numbers are there? The given digits are 1, 1, 2, 3, 3, 4. Totally there are 6-digit numbers. In that 6-digit numbers I can say 6 factorial. But 2 1s and 2 3s are repeated. 2 1s tell me 2 factorial and 2 3s tell me 2 factorial. So the distinct 6-digit numbers are 6 factorial by 2 factorial into 2 factorial. So 6 digits tell me 6 factorial, but the repetition I have to divide. So simplify the answer. 6 factorial meaning 1, 2, 3, 4, 5, 6 divided by 2 factorial 1 into 2, 2 factorial 1 into 2. Simplify and write the answer. 118. The second subdivision, when we form the 6-digit number, how many of these are even? What do you mean by even number? Even numbers end with, out of the given digits, 2 and 4 are even. So the units place, I can have either 2 or 4. So how many ways? 2 ways. The remaining 5 places, check out what are the numbers given. 1, 1, 2, 3, 3, 4. Either 2 or 4 is coming here. So remaining there are 5 digits. So 5 digits, but what is the repetition with how many ones? 2 ones and 2 threes. So what is my answer? 5 digits can be arranged in 5 factorial divided by the 2 ones I will put 2 factorial, the 2 threes I will put 2 factorial into the units digit either 2 or 4. So this 2 will come. Multiply and simplify the answer. What is 5 factorial? 1, 2, 3, 4, 5. 2 factorial 1 into 2, another 2 factorial into 2. Simplify the answer, we get 16. The third subdivision, how many of these 6-digit numbers are divisible by 4? When I said even, we said only the last digit, either 2 or 4. That will describe it is an even number. But when I say divisible by 4, divisibility of 4 tells me I must check out the last 2 digits. What are the digits given to us? 1, 1, 2, 3, 3, 4. The last two digits I must frame from here so that it should be divisible by 4. So if I check 11 cannot come, 12 can come. So last two digits can be 12. The last two digits, if I reverse, it won't come. So 32 can come. The last two digits can be 32, which is a number divisible by 4. The last two digits can be 24 also. So I have 3 different combinations. Divisible by 4 depends on the last two digits. So out of the given 6 digits, I can frame 12, 32 or 24. 34 not divisible by 4. 42 not divisible by 4. So the possibilities are 12, 32 and 24. Let me fix 12 here. The remaining, how many digits are there? 4. Remove 1 and 2 from here. The remaining, there are 4 digits. What is repeating in the 4 digits? With, if I remove 1 and 2, 1, 3, 3, 4. 2 3s are there. So what is my option? 4 can come in 4 factorial by 2 3s are there. So 2 factorial I must divide. The second case, 32 is here. So remove 32 from, what are the remaining? 1, 1, 3, 4. So again how many are there? 4 digits are there. Any repetition? Check it. With 32 I have removed 2 ones are there. So with 2 ones. So in this case I will say again 4 digits 4 factorial by 2 ones I will say 2 factorial. When the last two digits are 24. Now tell me, 2 and 4 I must remove. 1, 1, 3, 3. So again there are 4 digits, but what are the repetition now? 2 ones and 2 3s are there. So this tells me 4 factorial by 2 factorial into 2 factorial. So we have when 12 ends 4 factorial by 2 factorial, when 32 ends 4 factorial by 2 factorial, when 24 ends 4 factorial by 2 factorial into 2 factorial. My question is divisible by 4. So either this way or this way or this way. So it is OR condition. This or this or this it ends. It is divisible by 4. Whenever you get the OR condition, add it. So first answer plus second answer plus third answer. As we add and write, my answer is 4 factorial by 2 factorial 12. 4 factorial by 2 factorial 12. 4 factorial by 2 factorial into 2 factorial is 6. Altogether 30. So we can frame 30 numbers which are divisible by 4.